Sorry, I'm looking for something. Sorry. Are y'all done? Is everybody done? Hold on. I'm going to give you like 1 more minute.
There's a lot of sleep in there.
Oh, I did have a yellow one. You need a yellow? Oh, you got it? Okay. I'm going to pass around this bag. Please put the markers back in here. And just pass the bag around, please. All right, so look, we're going to say, class is officially starting here. My name is Robert DiGiovanni. I'll be the instructor for the class. The table arrangement right here is not good, so I don't want anyone to have their back to me like this. So what we need to do is just pivot that entire table so you're like this. Does that make sense? Pivot a little bit and move back a little bit. Over here, I think you want to sit like that. I don't think that's optimal. Over here. You're going to be okay right there in that corner like that? Okay. Feel free to move the chairs around. That's what I'm getting at, okay? Move things around. And then look, if you want to be up close, there's 2 seats right here. Okay, the point of this, you will turn this in. I'm going to make a photocopy of it and then I'm going to give it back to you. I am doing this because I think it's very important for you in college to be able to manage your time. It's one of the biggest deficits I see. A lot of times I'll have people who are like, hey, I'm an engineering major. I'm struggling in this class. And I ask them, well, how many classes are you taking? Oh, I'm taking 6 classes. How much do you work? Oh, I work, 40 hours a week. Okay. When do you sleep? When do you eat? Okay. There's reasons we don't hand out college degrees in 1 semester, right? You can't become an engineer in 1 semester. It takes time. And you may have a grand plan that, yes, they will let you register for as many classes as you want. But that doesn't mean you're capable of doing all of those classes. So it's important for you to lay it out, okay? If you have, what was yellow? Yellow's studying. If you have just a little bit of yellow on here, you have to be realistic. All right, this class is going to require anywhere between 8 to 10 hours of work outside of the classroom per week. This class alone, all right? You want to do well, that's how you do well. All right? And that's just an honest assessment of what it's going to take. So look at that, reflect upon it a little bit, you know, not now, but just think about it. And if I collect it and I get worried, I'll look at everyone's and I'll just see like, whoa, this does not look like this is doable. Then I'll talk with you, okay? All right, so does everyone know how to get to Canvas? Everybody know how to get into this? How you doing? Good. I'm going to assume you can get to our course, which we are in fall 2016, and we are section 8. Okay. Oh yeah, so I'm recording everything here, and the reason why the camera's set up the way it is to try and minimize the glare off the board. I don't know how, I'll check this first video when I post it later on YouTube to see how good that worked, and I'll adjust accordingly. But all of the videos with the microphone, everything will be up on YouTube later today. All right, so if you miss class and you're like, well, what do we do? Before you go text me or call me or email me saying, hey, what did I miss? This is what you missed. You go watch the hour 40 minutes that you missed, and then if you still have questions, you can reach out to me, okay? Now, we all know technology can be a little buggy sometimes, so I'm not guaranteeing you there's going to be a lecture every single day that's recorded. Sometimes the technology fails. So, all right, this is our main page. I know some of you have looked at this already. Show of hands, how many of you already been here? Anybody not been here yet? It's okay. Anyone not been here yet? Okay, so you need to go through this. Everything we need for the semester is here. I'm going to start with the syllabus. I hate wasting time on the first day going through a syllabus, but I have to make sure you're clear on the contract that we have between each other. Get the expectations established right away. So unless it doesn't want to load, if it doesn't want to, okay. So here it is. I will breeze through this quickly, all right? So we have, most importantly, my contact information. Stop moving. My contact information. This is my cell phone number, and I just got a new phone. I'm very excited about this. I actually got the Note 7. I'm not sitting here promoting it, but it has a stylus that I can write on. One of the big problems I was having with my students is that I give out my cell phone number, and people will text me. They'll take a picture of their work. They're like, I don't know what I'm doing wrong. They'll take a picture and they'll text it to me. And then I'll see their mistake, and then what do? Text an answer back. So this is going to allow me to actually write something down and text it back to you. And if you have a picture, and if it's a good picture, I can even like circle on it and like edit your own work and whatever. I'm excited to use it. We'll see what happens. But the important thing is you do have my cell phone number. If you send me a text, that first text you send me, make sure it includes your name, what class you're in. Okay, I had 3 Cal 1s, so make sure you put in there like Monday, Wednesday, 11 a.m., or you can say Section 8, whatever. Section 8. What's Section 8? Yeah, oh, Section 8, yeah. So y'all are Section 8, y'all are kind of my, I guess so. I won't say it. Okay, so can you do that first text message, just so I have archived like who you are? Okay. And then, see how that works out. My office hours, I'm actually in my office to help you. It means you can just come in and get help. I'm going to be there 2 hours before class. Okay, so Monday, Wednesday, I'm there from 9 a.m. to 10:45, and then right after this class, I don't have another class. This is my only class on Monday, Wednesday. So right after this class, we get out at 12:40. I'll be in there from 1 to 2:30, and then that's it. And now if you need to make an appointment with me, we can do something. On Tuesday, Thursday, I have a little less time, so I'm only there in the morning on Tuesday, Thursday. Got it? Fridays are by appointments. We have a lot of commitments. Faculty have commitments to meetings and things like that. Like, right, y'all don't have classes on Friday normally, unless you have a special class. That's so faculty can do all of our administrative stuff on Fridays. The book that you need for the class, this is it. Okay? Essential Calculus by Stewart, 2nd edition. I don't know how much this costs, but keep in mind, new?
Brand new, it's $293.
What? $300? Wow. Okay, so look, if you take the entire calculus sequence here, this book is good for Cal 1, 2, and 3. So whatever you paid for it, divide by 3. That's really what you're paying per class. Yeah, you can find it. It's all over the place. But you must have access to that book starting pretty much immediately. You need to go get that book, all right? Because your first homework assignment's right out of that book, and it's due next time we meet. When I say due, I don't mean like you're going to turn it in. It means like you need to have completed it, all right? Keep in mind, this is grown-up math, okay? I'm not going to take you by your hand here and make sure that you've tucked in your shirt and you tied your laces the right way. This is grown-up math. You have homework assignments. You're responsible. You do it. If you don't, we probably won't see you at the end of the semester. That sort of thing, right? You're going to get out what you put into this class. All right. I have a new calculator policy. I'm sorry this is small. I've been having some major problems with these computer algebra system calculators where students aren't really learning. And this is more for my online students than they are for the face-to-face students. So what happens is I go to give a midterm for my internet classes, and the first thing they do is they pull out the calculator and start punching away at it. And I've always said calculus is not in the calculator. Calculus is up here. Math is up here. So of course we can use it as a tool, but I don't want it to be the crutch, the thing that you depend on. So how many of you have a TI-89? 1, 2, 3, 4, 5, 6. I do not want you to go reinvest in a calculator, all right? I don't know how I'm going to handle this yet, all right? I don't want to force you all to go buy another $100 calculator. So can we just kind of play it out and see? Like that first test, I'll kind of identify who has the TI-89s, and I'll just keep an eye on y'all. Not like I'm going to watch you to make sure you're not doing certain things, but just I can always tell if a student is dependent on a calculator. It's not a hard thing to do. So this is going to be a very loose policy right now. I would just not recommend that you go buy a TI-89 right now. Okay, if you don't have one, just don't get one. Not yet. All right. Pardon?
89, you say?
89, that's fine. Yeah. All right, so objectives, outcomes, blah, blah, blah. I won't read through that. Okay, quizzes. So this is the way we're going to break down the course. I'm so sorry this is small, but you can read this later. We're going to have quizzes. Those are going to happen at any point in time. I could give you a quiz right now. I could give you a quiz at the end of class. I could give you a quiz at the beginning and the end of class. It doesn't matter how the quizzes are formed. It could be group quizzes. It could be, hey, I'm going to take attendance. There's people missing. That's a quiz grade. Whoever's here is going to get 100. Like, it doesn't, quiz can come in any form. Got it? All right? So be here. Be prepared. I may say, hey, I'm going to do a homework check. Let me see your homework. You know? So always bring your homework to class. I might use that as a quiz grade. With me? 15% of your grade right there. You're going to have 3 exams and a final. Each exam, 20, 20, 20. The final's 25. The final is supposed to encompass the entire course. So that's why it's weighted a little more. But when we get to the final, we'll talk about exactly what type of things will be on it. Just be prepared for it to be everything. So I don't want you to get this feeling that as soon as exam 1 is over, like I never need that information ever again. It's not like brain dump after exam 1 and brain dump after exam 2. How many of you need Cal 2? Show of hands. That's almost everyone, right? Almost everyone. Who doesn't? You don't need Cal 2. What's your major?
Biology.
Biology? Biology? Pre-med or no? 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 So they've been changing things lately. Anyone pre-med here? No? No? Okay. All right. Well, a lot of you need Cal 2, and I always teach Cal 1 as if you need Cal 2. And I promise you, you've probably heard, how many of you have heard Cal 2 is really the beast? Have y'all heard that before? No? Cal 2 is going to make you wish you were back in Cal 1, okay? It is so much more difficult than Cal 1 is, but the people who do well in Cal 2 are the ones that throughout Cal 1 really never had a bad test. You can't have there's nothing from Cal 1 that you are going to not need later. Does that make sense? So if you have one bad test in Cal 1, you can still pass the class, but that may come back to haunt you in Cal 2. So you want to be strong with all of the tests. Understand? Okay. That's why the final needs to be more of a comprehensive look at what you know. All right, what to expect. I've already told you I'm going to record the lectures. They'll be posted on YouTube. I'll show you where to get to those. Electronic policy. I'm big on electronics, obviously. I have cameras and all sorts of things, but I also understand how much of a distraction they are. So in my classes, I have a very strict policy that you are not to have your phone out. You're not to be messing around with your phone during class. Zero tolerance, right? I make examples out of people, right? I always have one person that has to be the one who gets, called out. So what happens if you have your cell phone out and you're sitting there chasing pokey whatever's all over the place? Whatever it is you're doing on your phone, if it's happening in this classroom, 10% penalty on your next exam. So that's automatic. You cannot get an A on the next test. All right? You'll be asked to leave and you'll be counted absent. And you only get 4 absences. So it's a pretty harsh penalty. I don't want to have to do it. I always feel bad when I have to do it that first time. My voice gets kind of shaky and I'm like, because I feel bad because I know what a big penalty it is, but you've been warned, it's in the syllabus. Now, if you're expecting an important phone call, I understand life happens, okay? Best thing to do, try and let me know ahead of time. Hey, I'm expecting something. I don't mind you stepping out of the classroom, taking it out there. I just don't want people answering their phone in class. I wouldn't do that either if my phone rang. I would be like, yeah, hold on, that's rude. So I expect the same from you. You can step out. Yeah, I mean, if it becomes an issue where you're stepping out every 3 minutes, within reason, all right? Just kind of imagine that you're kind of off the grid for an hour and 40 minutes, just off the grid. I have the same policy for sleeping or being disruptive. Now sleeping's pretty obvious, but being disruptive is kind of vague, and I intentionally make it that way. So I just don't want there to be any issues, with students. And if you're sleeping, I'm not a big fan of sleeping. I actually do not like it at all. All right, so 10 points off your test. If you are that tired, if you walk in here and you're that tired, it's best to just not be here. It's best to just take an absence than to take a 10-point penalty in an absence. All right, or if you're, how you get that nod thing going, if you're in that state, step out of the room, go lay down on one of the chairs out there. Just don't sleep in here. Got it? Okay. Dishonesty, cheating. I have zero tolerance for cheating, so if you're cheating, however that happens, it'll just be an F in the class. That'll be it. And then you'll have to go through and your transcripts will be put on hold. I kind of go with the full degree of the harshest penalty I can impose. Tutoring. So there's tutoring over here in room 316. And I would always go over there and ask, who are the good Cal tutors? Okay, there are very good ones over there, and there are also tutors that should not be tutoring Cal. So you always want to try and find someone who's finished out the Cal sequence, maybe someone who's like a math major who's taking junior, senior level math courses that's tutoring over there. You don't want the person who got an A in calculus last semester. Okay, you don't want that person because their understanding of Calculus 1 is a lot different than what they need to be able to help you. All right. The rest of this, I won't read through. Here's our schedule. That's kind of I'll show you that in a minute. It just eats up so much time. All right, so there is a quiz that's due, tomorrow by 10 p.m. You must come in here, you must click on that link, and all it is a yes or no thing or something like that where it says I understand the requirements of this course. And it's my way, that's like your signature on the syllabus. And then later on when you're sleeping and I take off 10 points, you can't say that you didn't know. Say, yes, you did. So you said you did, right? Okay. All right, what do y'all want to look at next? The schedule. This is the schedule you just download and print out. All right, and I've already done that. I have it taped to this thing and it just shows every day. It's really small print, but that's the only way I could get it to fit on one page. It shows what day, what we're doing, and then suggested homework problems. Got it? You just work through this. This is an important document because this tells you what we're doing today, what we're doing next class. And you'll see why that's important as I move through this. After the schedule, we have this thing called course videos. Now, these course videos will open up in YouTube. And these videos were made by me years ago, and they are just introductions to each of the sections. So theoretically, you're supposed to read about what we're supposed to do before you come here. That's the way math should work. Like, we're supposed to cover 1.3 today. You should have read that. You wouldn't know that, but you should have read 1.3 and then come to class. That way, the things I'm saying are completely foreign to you. That's the way it works in theory. Now, I understand that that doesn't happen. So what I've done is I've created videos for each section that give you an introduction to the definitions, the basic concepts. All right, this is not a full-blown lecture of the material, but it's just to get you acquainted, right? You should watch these course videos before class. Understand? Then we have the class lecture videos. Now that's what's coming off of that camera. And so that will be me doing examples in class and everything I expose you to here, you can go watch those. Got it? Then I just put these up this morning. So if you've been to this website, this wasn't here this morning. Homework solution videos. I've decided I'm going to make videos for all of the homework problems that I'm assigning. But that's very time intensive, and what I can do is hopefully stay ahead. I should be able to. I will not do every problem. What I'll do is, like, if number 1, 2, and 3 are all the same concept, I'll do one of those. And then I'll move on to the next concept. Make sense? So I've already done the homework videos. I'm sorry, the homework video for, whoa, sorry about that, whoa. Whoa. Let me shut me up here for a second. Yeah, this projector's not too good, but you can see it's just me in one of the offices downstairs, and I'm going to work through the problems. A little bit about YouTube, in case you're not familiar. You can change the quality of the video if you can't make out what's, if it's too blurry or something. Make sure I'm only recording in 720. Sorry, I'm not doing 1080, but the file sizes are too big. So I don't like to spend a lot of time like uploading, and so. But just make sure you're not like in some low-res 320 where it's all grainy and stuff. And then also, this is something that my students do. Somewhere over here, there's I think you right-click. No, where is it? There's a play speed. Oh, here we go. Speed. You can go, like a lot of students will watch my videos at like 1.5 speed, because then you don't really have to sit there the whole time. You can still make out what I'm saying, even though I'm like a little faster. But you can get through it a little quicker, right? So just keep those things in mind. See, I'm writing a little fast there. So hopefully these will be posted before those are due, right? That way you have something to reference. That's my big project this semester, is to make videos for that. And then I have files. This is where I'm going to have, everything that you need for the class. The schedule that I already showed you print out. Formulas, you're allowed to have formulas on the test. These are them. These are the only ones you're allowed, right here. You can't bring in like your favorite thing from precal that has the unit circle. Nope. You can have this. Everybody has the same exact thing, right? That's called fairness, right? Everybody uses the same. That's a lot of information here, all right? So what I would do is just make sure you're aware of this. Yes?
So when you say we can do that for an exam, like, can we print out all 6 pages?
Yep.
Okay.
Yep. There's conflicting ideas within math faculty about formula sheets. And my theory is kind of this, like, in the real world, you're never really trapped in a room with no resources, right? I mean, part of being a good student is to be resourceful and to know that, those formula sheets you have, like, to know what's on them. Like, know where to go. Like, yeah, I remember that's on page 3 because I've been using this all semester and I know where it is, As opposed to, like having I always think of these fancy calculators that people have. They don't know how to use them. It's just like eye candy, like on the desk. Like, yeah, it's pretty badass. I don't know how to use it, but it's a nice calculator. Like, you want to know your formula sheets. They should have like blood stains on them and stuff by the end of the semester, right? From paper cuts. All right. Okay. In those course videos that you're supposed to watch before class, right? Those course videos, I have a bunch of typed up notes. And you can actually download those typed up notes right here, and you can print them out. Now, I will say that these notes were made for printing, so I took out all the images. I took them all out. It's just really like the definitions and things like that. So it's a condensed version of the notes, but it's better than nothing, I guess. And that's for all 4 chapters that we'll cover. What else is in here? Old exams and reviews. Big asterisk next to this. I don't even know what's in here, okay? I just keep on throwing stuff in this. You know, if you see an old exam here from another semester, that does not mean your exam's going to look like that exam, all right? But this gives you some idea of the things I've asked in the past, all right? Any questions? I'm going kind of quick through this, but we've already eaten up half an hour. No? We're good? Grades. Your grades will slowly start to appear here throughout the semester. This is where you check, okay? And that's it. I don't see anything else. Okay? All of our communication, other than the texting each other, by the way, I'm not going to ever text you. I'm going to go, hey, you know, let's talk about some math. You know, it's always going to be me responding to you. So, yeah, sorry, I'm not going to try and motivate you to do that. All communication has to be done through Canvas. So there's an inbox over here, and I'm assuming you're all familiar with that. If you're not, please just talk to me after class. But do not send me an email from your Yahoo account or your Gmail account. I will never see that email unless I go looking through. We've got some automatic filters. Our email gets filtered out. And unless I go looking for it, I'll never see it. Okay? Also, the texting, although it's great, it's not official. And you know as well as I do, you're driving down the road, someone texts you, and you kind of glance down at it, right? And maybe you open it and then you forget about it later, right? So that same thing happens with me. So if you want something like official, you just need to send me an email. All right? No questions? All right. So what are we doing here? Should we talk about Cal 1 first? I guess we could talk about, anyone see the fight on Saturday? You know what? I wanted Diaz, but I thought it was a good fight. I thought he was going down in the 4th round. I thought Connor was going to go down, but
Maybe another minute he would.
yeah, another minute in the 3rd round. I think it might have been over. All right. Shall we talk briefly about what Cal 1 is before we actually get into this? All right. So let me see if I can do this easily. Whoa.
So is that something we could get from Wolfram?
What's that?
That other app that you had or program Wolfram?
Yeah, I'll talk about that in just a minute after we get to it. Yeah? All right. All right, so what college algebra, right? College algebra was just mechanical skills, right? That's all it was. Manipulation of equations, solving equations, right? Getting a basic understanding of what graphs look like. What was precal about?
It was a lot of trigonometry.
What's that?
Trigonometry.
trig stuff, so like sine, cosine, so you had these new trig functions.
Making it
Synthetic.
Solutions, is that right?
What are you thinking?
We did that
Synthetic division. Partial fractions, do y'all do partial fractions? Yeah. All sorts of, there's all, someone's, yes ma'am? Hi. Not right now. Are you supposed to be in this class? Okay, come on in, have a seat. Yeah. Okay, so precal was a lot of trig, right? So if I sit here and I say like, what's, cosine of pi over 6, everyone's gonna break out their calculators. What are you gonna do? Cosine of pi over 6? Uh-oh.
Draw it out in infinity.
It's been a while. Okay, so look, we all have to have, coming in here, some idea of the unit circle. That's one of the biggest things that you need to know, all right, is that unit circle. And hopefully you can get to a point where you can visualize it as opposed to needing to draw it out. But that takes time, all right? So a lot of what you did in college algebra and in pre-cal and every math class before that was kind of building you up to be able to do something useful with mathematics. And calculus is our first opportunity to tackle some things that you cannot do without calculus, all right? But I have to make it very fundamental to start, right? It comes down to a very, very simple problem. So here it is. If you have a function, which I'll just draw here, which I'll call that f, so this is x, there's your function. It really doesn't matter if it continues or stops. That could be a polynomial function, that could be a trig function, it could be a lot of different things, right? What we are interested in calculus is trying to find a single point on that curve, looking at that point, and trying to define the slope of what we call a tangent line. Now, before I can talk really about a tangent line, I have to tell you what we all know what a line is, right? How many points do you need to define a line? You need 2 points, don't you? 2 points will define uniquely a line. So if I just put a point right here, there's an infinite number of lines that go through that point. The one that I'm looking for is the one that just runs tangent to that curve. Kind of only punches through 1 point. And there's something fundamentally wrong with us asking that question. Because if you're trying to find the slope of the line, let me kind of zoom in on this. If I give you a point here, and I give you a separate point, then it's very easy to define a line through there, right? And the slope of that line, we say rise over run. We always define that with some formula. I think one of them was like y2.
Over x2 minus x1.
You remember this?
Yeah.
Yeah? Everyone remember that?
Yeah.
But it relied on you having 2 points, right? We call this point here x1, y1, this one x2, y2. And so as long as you have the points, you're good and you can find the slope. If I am only talking about a single point and a line through a single point, what happens to that formula? What's your rise? If you're only at 1 point, what's your rise?
It's me y over x.
Well,
Y is over 1.
look, y2 minus y1 says the difference between the 2 points, right? Vertically. This says the difference horizontally. Well, these 2 points do have a difference vertically and a difference horizontally. If I'm talking about a single point, does it have a vertical change? No. So it has no change, right? Over, what's the horizontal change? There is no change, right? And what you have is what befuddled us for a long time, and that is, what the heck does 0 divided by 0 mean? Undefined? What do y'all think? Yeah? Undefined. Well, we know a couple of things about division by 0. We know that if I said 4 divided by 0, that would be undefined, wouldn't it? Right? If I said 0 divided by 4, is that defined?
No, that would be 0.
That's just 0. So that's okay, that's not okay. 0 over 0 is kind of a very unique scenario because we were told at some point that anything over itself is what? 1? So you could maybe argue this is like, maybe it's supposed to be 1, but it's not. It's still division by 0, so it's undefined. But it's still an interesting question because there appears to be only one line that does this. Like, if I were to sit here and I draw this one instead, does that look like it's supposed to be there? Like, does that look naturally like a tangent line? Like it's just touching the curve at one place? Just barely touching? Yes, no?
Yes.
No.
Which one looks more natural to you, the red one or the blue one?
I would say the red.
The red one, right? Does everyone understand why I think that's more natural? Because it just kind of balances on there as opposed to cutting through. And there appears that if I pick any point on this curve, that there should only be one line for each of those points. There should be something. So there should be some way of defining that. And that's what this whole course starts at, is this idea of trying to define the slope of a line, okay, at a single point. And we have to get around this. We have to find a way to get around it. And that's what Isaac Newton was able to do. He was able to find a way around it so that he didn't have to compute 0 over 0, but he was allowed to actually get a numerical answer that corresponded to the actual slope of that line. And it involved what's called the limit. Okay, and that's the first section we're going to start with. Now, I don't want you to think that all of Calculus 1 is just that simple idea, but I will tell you, I mean, that is the womb of the calculus, all right? It is where it's all going to come from, is this idea of a limit. And then from there, you can go all sorts of places. Some of the things that we do later, let me just get to later. I want to get into the material. All right. So I use this program called Mathematica to do all my notes. And what's cool about it is I can animate these things. I'll make this bigger so everyone can see it. Let's try that. So I can animate these notes, see the things moving around and stuff. Now, you do not have access to these files so that you at home could do that. If you are interested in doing that, I have no problem providing you these notes. It requires that you download a thing called a CDF player, which Wolfram makes, and it's free, and then I send you the file, and then you can go home and you can mess with all this yourself. And if you're a computer science major, any computer science major? Then if you're really interested, you can actually get in here and see the code that I had to put in there to make all that stuff happen, to make this happen. It's not super crazy code, it's C++ based stuff, it's a lot of built-in functions. So if you're interested in that sort of thing, I have no problem sharing my stuff, okay? But you have to reach out to me if you're interested.
Yeah, I'm in computer programming and computer coding. I like a lot of coding. We'll talk later.
Yeah, talk to me before class or after class.
Yeah.
All right, so we are skipping 1.1 and 1.2 in the book, all right? This is review, college algebra, and other things. I recommend that you go watch the 2 videos, the course videos that I made for those, because I run through all the different things you should know about functions, power functions, rational functions, the essential stuff that you need to go forward in here. Then we just start with the limit. So we're going to do this graphically. All right, introduction. The question here is for us to discuss the behavior. I'm looking way up there at that. Discuss the behavior of this function around the value of x equals 2. So can everyone see this picture? Here's the function. I want us to discuss the behavior of the function around x equals 2. I don't see a ruler. Anyone see a ruler around here? No? No? It's okay. We'll be okay. All right, so when we say discuss the behavior around x equals 2, we're talking about that right there, right? That's x equals 2. And there's nothing going on down here. What we're interested in is the function, which is up there, right? So if I look up here, there's a point obviously right there. Can you tell how high that point is?
Yep.
What does it look like to you?
Looks like around
8?
8.
It's supposed to be. I know, from this perspective, it looks a little higher. It does. So that looks to be, if I were to label this point, it looks to be the point 2.8. And that would be something I could ask a college algebra student to do, right? What's the function's value at 2? 8. Okay, done. That's it. That's not what this class is about. What we're interested in is what's happening near 2. So if I pick a point right next to 2, something there. What's a point that's to the left of 2, but not quite 2? 1.9, right? Could you get even closer? 1.99? Could you get closer? 1.99, right? Yes? So will you ever run out of points to get closer? You could keep getting closer and closer, right? There's an infinite number of points, so you could always get closer, couldn't you? So if I take the value, let's say 1.9, and I plug that into the function, I'm going to land somewhere to the left of this, right? And a little bit below. So that value won't quite be 8, will it? Well, it's 7.9 something, who knows, right? We'd have to plug it in to figure it out. So when we say behavior near the value 2, we want to look at two aspects of it. What's happening to the left of 2 and what's happening to the right of 2. So if I'm to the left of 2, it appears I'm a little bit below the value of 8. But as I move closer to 2 from the left side, this approaches and gets closer and closer to this magic value of 8. Yes? So from the left, the function's value is getting higher, approaching 8. Yes? Okay. How about from the right side? What if I go onto the other side of it and I pick a number over here like 2.1? So now I'm going to be a little bit above, right? So that would be greater than 8. But as I move closer to 2 this way, it starts to come down, doesn't it? And it again gets closer and closer to 8. So from both sides, do you all see that? No matter which side I come in from, left or right, I'm going to be approaching 8. Yes? Okay, now with this animation you can do all this. I don't think I'm going to do it. But as you slide in, you can see here, as I move in towards 2 on my x value, from the left, notice my y values are starting to grow and get closer and closer and closer to 8, right? And then if I do the same thing from the other side, it first goes up and then it starts to come back down. But as I get close to 2, it eventually gets closer and closer to 8. Yeah? All right. There's a bunch of other stuff that you can mess around with on that. I'm not going to. I think you'll have the idea. That's not too complicated? Pretty straightforward? Okay. That's not a very interesting graph. This is more interesting. Same question. What's happening to this function? Or what's the behavior near x equals 2? Again,
It's greater than or less than 2.
we've got this break, right? Hold on. Got 2, right? So I've got this break in the graph. Totally different than what we had last time. Now if I approach from the left side, I start plugging in some values to the left of 2. I'm going to be somewhere on this piece right here, aren't I? Now, let me just pick one over here, 1. Okay, so I'd be somewhere over here. Now, is that close to 2? I could get closer, couldn't I? Now, just as we move over, these y values are starting to get bigger, right? And bigger, and bigger. And what are they approaching? What are the y values approaching as I come in from the left-hand side? So, yeah, it looks like it's approaching 8, right? Yeah. So it looks like from the left side, I'm approaching 8. What's happening from the right side, though? So let me back this out. Any questions on from the left side, it's getting close to 8? No? Okay, how about on the right side?
It just doesn't reach 8.
It's coming up. Here it comes. It goes up. kind of peaks out somewhere around there, and then as I get closer to an x value, as I get closer to an x value of 2 from the right, these are getting smaller, getting closer to 2, this value, this y coordinate, right now it's at what, 5.216, is starting to come down, isn't it? And it's getting closer and closer to what value? 4. Now, does it make it to 4? It doesn't make it to 4, right? Because there's not a solid dot here. Where's the solid dot? Up here, right? Yes? So it gets closer and closer. As you approach 2 from the right, the function's value gets closer to 4 without ever getting there. So 2 different things happening here. From the left, we approach 2, function's value approaches 8. From the right, we approach 2, function's value approaches 4. What happens at 2? What's the function's value at 2? What is f of 2? Look at it. Let me erase all my junk. Let me get this thing out of here. The function is the stuff in red. What's the function's value at 2? Just 8.
Yeah.
Because of this solid dot, right? Because this is an open circle, that means that point's not included. So at 2, it spits out 8. Got it? So f of 2 is 8. But what happens, I'm just trying to recap everything. What happens at 2, it's 8. What happens as we approach 2 from the left? It approaches 8. What happens as we approach 2 from the right? It approaches 4. Understand that concept? Fundamental. If that's a gray area already in your head, you need to ask questions. We good? Good, good. Okay. All right, let's look at a different one. A little bit different. So I'll start with this. I put way too much water on this thing. Let me start with this. What's f of 2 here? 6, right? Plug in 2, spits out 6, done. That's college algebra. Calculus perspective now, what's happening is we're approaching 2 from the left side.
During the
8 again, right? It's an open circle, right? That does not matter, okay? This is the way I want you to look at it. In college algebra, f of 2, you went to 2, you looked for a dot, didn't you? And you just ignored everything else. What I want you to do now, when I say approach 2 from the left, I want you to ignore that middle strip completely. Ignore what's happening at 2 completely. And just tell me where it's headed. Where's that headed? It's headed to 8, isn't it?
Yes.
From the left. Understand? How about from the right? Where's it headed? Headed to 4. All right? So we need to now try to get some notation established. How do I write this? Well, obviously, if I want to just tell you what's happening at 2, I'm going to write that. How do I tell you what's happening as it approaches from the left? This is what we write. Lim, which stands for the limit. Lim. Below it, I'm going to tell you what x value I'm approaching. X is approaching, what here? What's the x I'm approaching? No, that's the y value that's coming out. I'm approaching 2, right? So I'm telling you, by writing this down, I'm telling you, just go look at 2 and tell me what comes out. You tell me 6. Okay, done. This is telling you, look, we're in a calculus class. I want you to look at 2, okay, coming in on the sides, but I want you to only look on the left side, this way. To tell you that, I have to put a little negative above this too. Okay, so looking at it from a calculus perspective, this is a limit. I want you to approach 2 from the left. Negative means left side. And the way you can remember that number line, negatives over here, positives over here. So negatives, you're coming from the left side in. Got it? All right. And then what I'd write is this. F of x equals 8. This is the proper notation we use. Now, I will run through all this again so you can be clear on it. Limit means you're going to approach the value. You're going to approach 2 from the left-hand side. And what you're interested in is the function. What is the function doing as you approach 2 from the left? Got it? Well, what is it doing? It's getting closer to 8. We agree with that?
Yeah.
That is the proper notation we will use to represent what's happening up there.
Same goes for the right side.
Yeah, so let's see, how would it be for the right?
It's like x to 2.
X to 2. What though?
Just positive.
Put a little plus on the top right. That means you're going to come in from the right side instead of the left. And then you put f of x, because that's the thing we're interested in, right? This is the y value. F of x is the y coordinate. And what is it approaching? 4. That's right. It's 4. So this is the notation that matches up with this picture. Got it? Questions? All right. Which one do I want to look at? I want to look at this one right here. That should look kind of familiar. Rational function. This is the actual function right here. 2 minus x over x squared minus 4. It's a rational function. You do have a horizontal asymptote. You also have a vertical asymptote. And you have a hole. You got a lot going on here. So let me ask you first. I might need to zoom in on this so you can see it. Let me do it for you, okay? I'm going to move it for you so you pay attention to everything here. I'm going to come in. I'm approaching. This is 2. This is x equals 2 right here. I've been sticking with 2 the whole time just to keep the same theme, okay? We could be approaching any number. What's happening here is we approach from the left-hand side. Can you tell?
You're coming from the left.
Come from the left. Can you tell where it's getting closer to?
Getting closer to 2, yeah.
We're getting closer to 0, right? As a 1, is that what you're saying?
No, as I approach 2. If I go out forever, it looks like it will approach 0. But I'm saying only the 2.
Oh, only the 2. Okay.
Yeah, and I might have to go in a little slower here. Yeah, can you see it? I'm actually moving to the right. I don't know if y'all can tell.
Yeah.
What does it look like it's getting closer to? Negative.
6, 5.
Up, careful. That's the x value.
Now we're looking
Right.
at 0.227 something.
Oh, hello.
Can you tell?
Negative 0.25.
Negative 0.25 is what it looks like it's doing. Can you all see that? The y value.
Negative quarter.
The y value looks like it's around negative 0.25 as I get closer and closer. Now, the only way you can do this is by you using my computation, right? Otherwise, it would be hard to tell. But it looks like from the left, that's what it is. How about from the right? As you approach 2 from the right. So here I come. Yeah, it's looking like it's the same thing, right?
But it's pretty much x to plus. Since it's coming from the right.
Yeah, the 2 notations we would have would be limit x approaches 2 from the left of the function. What does it appear to be? Negative 0.25, right? It appears to be. And then if I change that from the right, it's what? Same thing? Now, if they're the same answer, if we're getting the same thing from both sides, we have a more condensed way of writing it. Here's what we do. Were there any questions on why these are these values? No? Okay, so if we have the same answer from both directions, then we can write this down, and it is implied that it's both from the left and the right. Right? So it's kind of like this. You remember when you were doing square roots? You didn't have to put the 2 out here? It was understood? If you write a limit like this, and you do not put a plus or a minus on the top right-hand corner, that means you have to look from both directions. That means from both directions, the answer is negative 0.25. Right? But if it's there, that means only from that direction is it. Hey, day one, man. Day one. Go walk in the hallway. Serious, go. Yeah, go walk around. Go up the stairs, go down the stairs a couple of times. Get your blood flowing. It'll wake you up. Push-ups, whatever. Jumping jacks. Okay. I do have one other thing to ask you about this. I wanted to clear all this other stuff out of here. I'm trying not to put y'all to sleep on the first day. Okay. All right.
What are we trying to do about that?
What's f of 2? So this is back to college algebra now, right? Okay, so we have to be careful in the language. We want to be real careful with our language now. You said does not exist? Undefined. Okay, so we are going to reserve the word undefined whenever the function is not defined, right? This function has a hole in it. It is undefined there. So you would write here, don't put equals, just put is undefined. So there's something interesting happening here. You actually, the limit for this function at 2 exists, doesn't it? We just said that a second ago. The limit as x approaches 2 of this function was negative 0.25. That's what you all agreed with, right? The limit exists. As we approach 2 from both sides, it is headed somewhere. This is where it's headed. But when you get to 2, the function completely falls apart. Yes?
Is it f of x or f?
Where here? Yeah. X. See, we're letting x, this x is approaching 2, right? Good question. Now, this is actually tied back to the first problem I put up on the board about that tangent line on that curve and how we couldn't define it because we were getting 0 over 0, right? I want you to look at this function right here. Plug in 2. What do you get on the top? Can you all see that function? You get, what, 2 minus 2 on top, you get 0 on top, and then what do you get on the bottom? 0. You have 0 over 0. We know that at 2 it's undefined, but as you get closer from both sides, you're actually getting a numerical value, aren't you? And that's what's going to allow us to find a tangent line here. We know that if we take, let me zoom it in a little bit. If we take this point and this point, we can always define a line through them, right? And that line will always have a slope to it. And if I take this point and start to slide just this one over, I'm going to have a line, right? All the way until I get to where? Right on top. And as soon as I put the 2 points on top of each other, the whole thing falls apart, doesn't it? That's kind of what's happening here. You have a function that it's fine until you get to that point and then it blows up. It's undefined. But there's still some numerical meaning to what was happening really, really close to that undefined point. Yes? So that's going to save us. All right. This is an interesting function. We're going to study this more later. Sine x over x. So what I'm interested in here is what's happening at x equals 0. So what's f of 0 here? Sine of 0 over 0? What's sine of 0? 0, good. So f of 0 is 0 over 0. This is undefined. I guess he went for like a mile jog or something. Gee.